Today we're going to start our next unit, which is on oxidation and reduction, and you can find this information in sections 11.1 to 11.3 in your textbook. So first let's talk about what oxidation and reduction are. So oxidation is the process whereby a reactant loses one or more electrons. And I have an example of that here. So if you have sodium ions and they each lose an electron, then they now have a positive charge. And so sodium solid going to sodium with a positive charge, or sodium ion, is one example of an oxidation. Okay? In a reduction reaction, the opposite process happens, and that's the process whereby a reactant gains one or more electrons, okay? So the example I have here for a reduction is chlorine gas, which has an equal number of protons and electrons. If each one of those atoms gains an electron, then we end up with two chloride ions, two Cl minuses. All right, and one way to help you remember this, well, there's actually two different acronyms here. The first is oil rig. Oil for oxidation is loss, and rig for reduction is gain. So when we reduce, something's reduced, it gains electrons. When something's oxidized, it loses electrons. And another acronym is Leo, the lion says grr. So Leo for lose electrons oxidation, and grr for gain electrons reduction. All right, and then the other thing I want to just briefly mention is half reactions. And half reaction is one of the two equations that I've shown above. All right, so when you put them together, you get a redox reaction, but when you have one of them independently, where you still see where the electrons are coming from or going to, that's called a half reaction. Now, if we put together an oxidation reaction and a reduction reaction, we can see that if electrons are lost in one side, so over here we have the oxidation of iron to make iron 2+, and if we lose electrons there, and we can sort of harness those electrons and move them through a wire over to a reduction reaction where we have copper 2+ ions that are gaining electrons, then we can be using the chemical properties of these metals to move electrons in a particular direction, and this generates an electrical current. So electrochemistry is the study of the relationship between electrical energy and chemical change. So here we have two different chemical changes. We have iron going to iron 2+, and we have copper 2+ going to copper. And the result of those two reactions working together is that we have electrons flowing through a wire, which generates electricity, and in this case lights a light bulb. So when we combine these chemical reactions in this way, we get what we call a voltaic cell. So a voltaic cell is just an apparatus where we have an oxidation and a reduction reaction happening, and we can generate electricity by the flow of electrons through a wire. All right. A battery is very similar to a voltaic cell. It's just an all-in-one contained unit, and that's how we use batteries to generate electricity. And they can come in either disposable or rechargeable forms. All right, and the design differs a little bit, but they both follow the same principle, which is that you have a material that's oxidized and a material that's reduced, and they're connected by a medium in which electrons can flow. So on the previous slide, that medium was the salt bridge, and in a battery it's designed slightly differently. So here we have an image of a dry cell battery, and I don't expect you to be able to recreate this image, but just wanted to show you that a lot of the same pieces are here. So in this particular redox reaction, the oxidation is zinc going to zinc 2+. And losing 2 electrons, and the reduction is ammonium ions gaining electrons to make ammonia and hydrogen. All right, and so this is all contained in one piece, and you can see that there are various layers in the battery, and then there's a graphite rod in the middle that allows the electrons to flow in and out of the battery. All right, so just a few terms to make this a little clearer and make sure we're all using the same language. The electrode is any material that conducts electrons into or out of a medium in which the electrochemical reaction is occurring. So that could have been the zinc metal or the copper metal in the voltaic cell that I showed you in the beginning, or it could be the graphite rod or the zinc in the dry cell battery that I just showed you. Okay, and then the cathode is the place where the reduction happens, and the acronym or sort of thing to remember that is red cat. And then the anode is where the oxidation occurs, so that's anox, right? So that can help you remember what the cathode is and what the anode is. Okay, and so these reactions look kind of complicated, but really all it is one thing is prone to losing electrons and another thing wants to gain electrons, and these two things work together in one direction so that we get electrons flowing in one direction, and those electrons flowing are what generates electricity.